is a function? Well, a function is a process or a rule that we apply to an input to get an output. So I've got an example under here. I've written underneath this diagram, f of x equals 2x, where y equals f of x. What does all that mean? Well, it means that I'm going to apply a function to x, x being our input. F of x is the way we write that in notation. Doesn't have to be f, but I'll go on to that in a bit. The standard way of writing it normally would be f of x, where x is our input. The function I'm applying, or rule that I'm applying here, is 2x, or 2 times the input, where my output is going to be y. So I say y equals f of x. So I could write y equals 2x, but here I'm defining it with a function. Applying the rule 2 times the input gives the output y. Another term we use is that we say that x is the independent variable. It's just a variable. It could be anything at this point. It's independent of any other items as far as we know in this circumstance. Once we've applied a rule and we get an output, that is still a variable. It could be a large number of different numbers, but it's dependent on the rule. So we call the output of a function the dependent variable. In this case, where I have f of x equals 2x and y equals f of x, the input x is called the independent variable. The rule is double the input, or multiply by 2, and the output y is called the dependent variable because it's dependent on the rule. So for example, you're given a rule that says the input is multiplied by 3, then the result is divided by 4. How would you write that in terms of algebra? Well, you'd start with f of x equals. Now the input has to be multiplied by 3. So the way we put that is multiplied by 3 or 3x. Then the result of that is divided by 4. So that process happens second. So it would be 3x divided by 4. How else could you word that? Look at those numbers. Well, rather than saying the input is multiplied by 3 and then the result is divided by 4, we could say the input is multiplied by 3/4. Both of those will be fine. Example 2. You're given a rule, the input is cubed, and then 1 is divided by the result. How would you write that in mathematical notation? Pause and have a think about that if you want to. Well, again, start with f of x in this case. The input is cubed, so we're going to have x cubed. Then 1 is divided by that result, so we have 1 over x cubed. So our function is f of x equals 1 over x cubed. Let's reverse the idea. If you have the function f of z equals 6z plus 3, yes, I've changed x to z, it doesn't matter as long as the letters match in the function and in that starting f of, function of terminology. How would you describe the order and processes? How would you describe that using words? Well, I'd look at that and go, well, the first thing I would do with z, any number, is multiply it by 6. And then I would add 3 to that result. So I would say multiply the input by 6, and then 3 is added to the result. You don't have to put to the result, but it's a nice way of writing it. Example 4, if you have the function g of z, this time I've used a g instead of f. My function is g of z. If g of z equals z plus 4, all in brackets, all squared, how would you describe the order and the processes? Again, pause and have a think about that. Well, again, you want to start with what you actually do with a real number in that scenario. So in this case, if I had a real number, I would add 4. So I'd say 4 is added to the input, and then the result of that is squared. 4 is added to the input, and then the result is squared. Seems pretty simple, but you have to get used to thinking about those processes in that way. But why are we doing this? Why are we looking at functions of process? Well, mostly what we're doing is looking at how we map from one set of data, the inset set of data, to the output set of data. So on the left we have set X, capital X in this case, and on the right we have set Y with a capital Y. So f of x, or a small x, represents an input variable, that independent variable from set X. That, by applying a function, maps then to the output set Y with a capital Y. The outputs of each individual variable being the dependent variables of those functions. So try and remember some of that language because it's important. So on the left we have set X, a series of numbers, data. We apply the function to all of them and we get a new set on the right, set Y. The set we start with, the data we start with, is called the domain, which we looked at, if you remember, with graphs. And the output set is called the codomain, also called the range, so the range of outputs. So here's another example. Given the rule, square x and multiply the result by 2, and then add 3 to that result, have a think about how you'd write that in algebra, in mathematical notation. Pause if you need to. Well, in mathematical notation, f of x equals the square of x, x squared, multiplied by 2. So we're multiplying the result of the square of x, the square of x by 2. And then we're adding 3 to that result. So if I write that down in algebra, I've got x squared times 2 plus 3. Because the x squared times 2 is done first, I put it in brackets, although of course it's a multiplication, so I don't actually need to, but it's to make it clear to you what's going on. And if I process that out, I go from here, x squared times 2 plus 3 goes to just 2x squared plus 3. That's our function, gone from words to mathematical notation. The domain is a set of real numbers we put in, and the range is the possible output. Now I can tell you for this function, where f of x is 2x squared plus 3, the range, the output, is 3 less than or equal to f of x, less than or equal to infinity. Now there's a lot going on there, isn't there? If you're not used to them, hopefully you will be, but if you're not used to them again, I think I would have gone through this last week. But we have this symbol here, which means less than or equal to. If you're not familiar with that, go and have a look at it up on the internet because you need to know that one. And we have this symbol here, which is infinity. And that basically means going on forever, going to the highest number forever that you can possibly imagine, or the number that you can't. In this case, for f of x equals 2x squared plus 3, the possible output, the range, is 3 less than or equal to f of x, less than or equal to infinity. That means that all the results of f of x, the function that we're applying, have to be between 3 and infinity. So the minimum number we can have is 3. Now, why is that? Pause and have a think if you're not sure. Well, here I've applied some data. I've put some data in. I've got set x on the left, individual variables x, and on the right hand side I've got set y, where y, the individual variable, equals f of x, which equals 2x squared plus 3. And then what I've done is I've graphed those. So this on the right hand side is the graph of the function. So it's the graph of f of x equals 2x squared plus 3, where we have our x-axis going across and our y-axis going up, which represents f of x. Now here, having graphed it, I can see that the minimum point is here, and that is 3. Now that makes sense, because where we have 2x squared, we know the results are always going to be positive, because with x squared they are. If you square a negative, you're going to get a positive number. The minimum point for that is going to be 0. 2 times 0 is nothing. And so our minimum point is going to be 3, because we add 3 to 0. That's what defines the output range for this graph and for this function. So here's another example like that. Here I've asked you to evaluate f of x equals 2x minus 4 for the domain 0 less than or equal to x less than or equal to 4. So in this case, what I would do is that's actually not that many numbers in that domain. It's 0, 1, 2, 3, 4. So I would start with f of 0, which I would write like this. Apologies for the writing with a mouse here. So f of 0 equals 2 times 0, because I put 0 into that x position. 2 times 0 minus 4, which is going to be 0 minus 4, which is going to be minus 4. Then I evaluate that for each of those numbers. So I do f of 1, f of 2, f of 3, and f of 4. Pause if you want to have a go at doing that to practice. If not, here are my answers. So I've processed all of the numbers on the left, the input numbers, the domain numbers, into f of x, and on the right hand side I have my output values for set y, f of x, or y. So you can see on the right hand side I have f of 0 at the top, which matches my sum, minus 4. I've got f of 1, which is minus 2, f of 2, which is 0, f of 3, which is 2, and f of 4, which is 4, because 2 times 4 is 8, minus 4 is 4. So for this specific domain of 0 is less than or equal to x is less than or equal to 4, the range, the output, is between minus 4 and 4, which we write as minus 4 is less than or equal to f of x, which is less than or equal to 4.